Guys, do you remember the dipole force and London force or London dispersion force, or we tend to say dipole interactions and London dispersion interactions. Okay, today I will tell you here, I have written the dipole force and London dispersion. Basically, the dipole force you can get in polar covalent compounds. If I write here, there are many molecules of hydrogen chloride, or let's say here, hydrogen chloride connected with another hydrogen chloride, sorry, and here connected with another hydrogen chloride. Okay, so here we have three different molecules of hydrogen chloride. So it is negative charge slightly because it is more electronegative element, so it is slightly positive, it is again slightly positive, it is slightly negative, hydrogen slightly positive and chlorine slightly negative. Okay, so here what happens, this interaction is known as dipole interaction, because here this is one pole, imagine this is another pole, we just imagine. So there is formation of dipole force. So it is known as dipole force. Okay, and even this also said to be dipole interactions. Alright, how about London dispersion force? Imagine there is a neutral atoms, like in terms of inert elements or noble gas elements. Okay, let's say this is the element or atoms. Here, let's say that there are positive charge also, and randomly there are some electrons. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are some electrons. So, one point of time, these electrons actually will come apart. Okay, these electrons will actually come the other side. Okay, let's say 1, 2, 3, 4, 5, 6, 7 electron is right side and the remaining 3 electrons is left side, for example. Okay, so because of the density of electrons, this side will become slightly negative and this side will become slightly positive. So here dipole is created, but it is not real. So London dispersion force is actually a hypothetical force. For a fraction of times, the dipole is created, the positive charge and negative charge is created. It is a dipole is created. It's an imaginary force, or it is a imaginary dispersion force, you can say. So similarly, we have chlorine molecules. So there are many molecules of chlorine gases. So basically here we can write like this: chlorine molecules here interacted with another chlorine gas, interacted with another chlorine gas. Okay, so this basically what happens, in this case, an imaginary pole can be created in terms of positive side and negative sides, as I explained here. Okay, one point of time that charge distribution can be seen. Okay, and now look at it, here is positive charge, negative charge. Because of this negative charge, it will induce and it will form as a positive, and again it will become negative. It will induce here, so it will become slightly positive and it will become slightly negative. Okay, so this interaction is known as London dispersion interactions, or London force is seen here. So this force is temporary force, and dipole force is always permanent force, students. Remember that. Okay, so now we have here, this force is actually called London dispersion force or London force. Here also you can find London force. And this basically actually an interaction, weak interaction, I will say, in fact, how the chlorine molecule is actually connected by means of the weak force of attraction. So London force is a very weak force of attractions. However, dipole force is stronger than London force. So you have to remember, so it is a temporary force. It can be created instantly and it cannot be last for long. Okay, so that is why it is called temporary force or very weak force. But dipole force is a strong force where we can find it, in between hydrochloric acid, in between different molecules of HCl, like here chlorine and this hydrogen, this interaction. This interaction is called dipole-dipole interaction. It is a permanent force, but London disperse force is a temporary force. I hope it is very clear for you. Thank you guys.